So our final presentation, where's Dr. Durrer? Oh, there she is. So Dr. Katherine Durrer from Texas is going to give us an update. She's presented at this conference both the last 2 times, right? She was very happy that she's on Friday and not Sunday this year. So she's going to talk to us about progress in the probiotic therapy.
Thank you for inviting me back again this year. It's been a wild ride since we started about 5 years ago. I'm going to go back to the beginning and try and get everybody up to speed who hasn't heard this presentation before. So my name is Katherine. I'm currently doing the name change, so in the future you'll probably just see Durrer, but since many of you have seen Demming, I've got both up there. I'm now working at the University of North Texas, the Health Science Center, rather than the main campus up in Denton, and we are continuing with the work. So, where did this idea come from? In microbiology, they teach us bacteria can eat anything. You obviously know that foods are eaten by bacteria and molds. That's why we put things in the refrigerator. It's why we cook our food. Those of you who garden know that compost is greatly assisted by having bacteria living in your compost. And to give you an idea of just how diverse bacteria are, yes, there are bacteria that can eat nylon. They use it as a food source. So whatever it is, there is something out there that can eat it. And in fact, there are bacteria that can use phenylalanine and have enzymes for degrading it for their own purposes. As you have heard over the past several years, one of these enzymes is Phenylalanine Ammonia Lyase. It does not work the same as the enzyme in the human liver. It takes phenylalanine and it makes ammonia and tranexamic acid, both of which are safely cleared from your body, no toxic side effects, but it does not make tyrosine. One hurdle at a time, right? So my hypothesis, given the roles of the gut microbiome and given what bacteria do in general, is that we could genetically modify a probiotic with a PAL gene to compensate for insufficient phenylalanine hydroxylase activity in a host. We set out to do this with mouse-specific studies to see if it works. Before we ever go anywhere near a human, we need to know, did it work, or was this just a crazy idea? We selected a mouse-specific probiotic strain. It was a Lactobacillus, and we have to select our probiotics appropriate to our host, because saying you're using a Lactobacillus, although to all of you this sounds well and good, it's a Lactobacillus is a Lactobacillus, it's like saying you have a dog. A Great Dane does not have much in common with a Chihuahua. So if you want it to do a specific job, you need to find the right dog. So this was our winner. We then chose the AV-PAL gene based on several characteristics of function that we needed in this treatment. Now we need to get the DNA into those probiotic cells. For this, we made little circles of DNA that are called plasmids. They're extra DNA for the cells. It makes it much easier to alter their DNA on a temporary basis. And on the left, you will see what says control. Control, in this instance, means placebo. So there is no PAL gene in it. It's just there to see what it looks like, give you some background. What does this probiotic do on its own? On the right is our treatment vector, where we added the AV-PAL gene. Now we've got to get these little circles of DNA into the cells. And for that, we quite literally electrocute them. Once they've been electrocuted, small pores open in the cell and the plasmids can go in. We then have to see which cells took up our DNA. We test for that. And then, of course, okay, great, we put the DNA in. Is it doing what we want it to do? So for this, we did testing in microplates, so think of it as a very small petri dish. The open white circles are the cells that are the treatment. They have AV-PAL. We were looking for that tranexamic acid that is produced when PAL cleaves phenylalanine. And quite clearly in the treatment cells, we were getting that response. The cells in black hugged the 0 line. So our control, or our placebo, did not make tranexamic acid. It's not an inherent property of these cells. They don't make tranexamic acid on their own. Great, we've made what we want. Next hurdle. We need to use the PKU mouse model. For all of its flaws and imperfections, it's a pretty good place to start. In this particular, okay, it didn't load the line, but the mice, you do not see phenylalanine levels above 250 micromolar if they are healthy. So you can quite clearly see in this graph who has PKU, because they are all sky high by comparison. They have about 10 times more phenylalanine than their healthy littermate counterparts. We have established the mouse model. It's very well known. Most of you in here know a good deal about it at this point. We had to figure out, how do we get it to work? How do we feed it to them? How do we process it? How often do we have to change the food? Any of you who've taken probiotics know some of them have to be refrigerated, some of them have to stay in sealed packages. We ought to go through all of that. And in our first successful test, we had these 2 boys that we tested. They started out with about 250 micromolar of phenylalanine in their blood. After 4 days of eating the probiotic powder mixed in with their food, their blood phenylalanine went down to 1,600 micromolar. So we were excited. We had a little party. It actually was working. What we needed to know, however, we kept seeing that same drop. When we fed them our probiotic, they only ever went down to about 1,600 micromolar of Phe. That would not be a good level for everybody in this room. So we needed to know, will it work if the diet is starting phenylalanine at a lower level in the blood? To do this, oh good, it's on there, I just can't see it on this bar. We tested mouse chow with different phenylalanine contents, and the black bars for each chow are showing you day 0. So this is when the mice have just been eating the food that is indicated. After 6 days of eating their food with the probiotic mixed in, you see the gray bars. And you'll notice that in every single group, there was a reduction in blood phenylalanine when the probiotic was added to the food. So we were not hitting a threshold. It was probably more like you're looking at a car factory. They can only make so many cars in a day, no matter how many parts are delivered. All those studies are great, but they're pretty short. So we wanted to know what happens if we feed it to them for longer. Days in experimental timeline, this is because we did not, it was more than just feeding them the treatment probiotic. So on day 0, again, they've just been eating food. On day 4, we started feeding them the placebo, and we drew blood on day 7. So they'd been eating placebo probiotic for 3 days. You'll notice that there is no real change in their blood phenylalanine levels. If anything, in this case, it went up. On that day, we switched their food so that they started eating the treatment probiotic with their food. And 7 days later, which is D14, we drew blood again. And you'll notice that we got the expected drop in phenylalanine. They continue to eat the treatment food. And on day 21, we collect blood again, so they've been on it for 2 weeks, and they've still got a drop. Excellent, because by then in a mouse, you're going to see an immune response if you're going to see one. We stopped feeding them the probiotic on that day. You will notice that 9 days after we stopped feeding, at day 30, they still had lower blood Phe, and at day 120, which is 3.5 months after their last feeding, they still had lower blood Phe. But what we were able to test for, that probiotic we selected, when I said it's like picking the right dog, we might have chosen a little too well. It hung out in their intestine at this point where we were still seeing the blood phenylalanine drop. We were still seeing some of the probiotic alive in their feces, meaning it was still in their gut. However, when we looked at 8 months after their last feeding, the probiotic was gone. So it did eventually go away, but the reason we saw this drop for so long is because the probiotic had set up, I guess you would say, a vacation home in the mouse gut. One of the driving questions I got from the Scientific Advisory Board, from the PEG-PAL and the initial naked PAL studies, do we have an immune response? The answer is no. One of the reasons we put it in the gut was an attempt to get around the immune system, keep it from recognizing what we were giving the mice. And it seems to have worked. If you look at these, I'm indicating 3 of the mice from the previous chart. When you look at an immune response, keep in mind that a 2 times difference is not much of anything. You want to see at least a 5x increase before you say something has happened, because your immune system is one of those all or nothing. And there is some cross-reactivity. So this is like saying one of your immune responses has learned to recognize cars. So it might also recognize trucks a little bit at some level. So you'll look at mouse number 4, you see it recognizes it a little bit even on the very first day, pre. That's just because that mouse had already learned to recognize cars and we were giving it trucks. You'll notice that that response was basically gone by 4 months, so whatever it had been responding to, it must have gotten better. But in none of the mice that we ever tested did we see an immune response. Why didn't we keep testing the mice to find out our perfect dose? Very simple answer. Mice are not human. When you are calculating the amount of phenylalanine your PKU children or your PKU selves are allowed to eat, and you compare that to a normal person, the normal person eats approximately 4 times less phenylalanine per day per unit of body weight than the mouse does. In addition to that, the mice pass their food through their gastrointestinal tract much faster. How those 2 things are going to affect our treatment, we have no idea. So even if we found the perfect dose for a mouse, it may mean nothing when we move to people. So instead, we chose to keep moving forward towards making our humanized version. So what have we done and what are we doing? We have selected a human-safe probiotic strain. It's been used in yogurt cultures for over 40 years. We're going to use the same AV-PAL gene, but instead of putting it in a little separate circle of DNA, we're going to stick it straight into the chromosome so that it can't move. It has even less potential to move around. Again, we have to go back and we have to test for the Petri dish activity, make sure the enzyme still works in this new Lactobacillus. Again, it's like looking at different dog breeds. We need to make sure that something didn't change. We'll need to figure out how to freeze dry it. We use it as a powder so that when the final product comes out, it will either be a powder you mix into milk, applesauce, or it can be taken as a capsule. We need to figure out the best way to make that powder so that it does its job appropriately. Once we have all of that information, we will start on our long-term mouse study that is considered preclinical data to approach the FDA for clinical trials. Right now we have that human-safe probiotic strain, and we have successfully gotten foreign DNA into it. We did a test run, not with our gene, but with less expensive DNA. We've got all of our DNA pieces ready, and we have started breeding the number of mice we need for that large number study to make the FDA happy. In fact, our breeding, we've managed to do something a little new and different. We're the first, without having, I guess, a permanent treatment. I know Carrie has done gene therapy treatments that allowed PKU female mice to breed successfully. We figured out a diet that works to allow the female PKU mice to breed successfully. So we can expand our colony faster. This is exciting for anybody who's a scientist in the room, probably not for the rest of you. Because anyone who works with these mice knows it can be a royal pain to get them to breed. Anybody who wants more information about that, let me know. Also, we had to have the mice re-derived because they had a virus that we couldn't get rid of without doing in vitro fertilization, which we did not have the facilities to do. At this time, Jackson Labs is working on doing a new strain deposit. So at this time, they only have the BTBR version of this mouse, the brown. Hopefully within a few months, you'll be able to purchase the black mice from them. That's what everybody uses, and soon it should be available for everybody. We won't all have to bother carry when we need mice. In conclusion, our mouse work proved that we could get a lactobacillus to function in vitro in that petri dish, making good enzyme that did its job. When we gave it to the mice, we could see between a 30 and a 40% phenylalanine drop on regular chow, depending on how long we treated them. And we never found antibodies to AVPAL in the mice, indicating that we could not find an immune response. There are obviously many people to thank with this. My two advisors, current Dr. Allen and previous Dr. Hunt von Herbing. Chantel Willette helped me with many of the mouse experiments. Without her, I wouldn't have had the hands to get this done. Funding. The funding that you guys provide is a godsend. We cannot do without it. As they said, getting in money from the NIH is very, very difficult. And we had funds from here, and we've also received some funds from the Great Britain Society, which is the NSPKU. Trayer Biotherapeutics has been helpful in getting us through some of the preclinical strategies. We have some colleagues in New Zealand that helped us out with some of the quirks of the bacteria we were using. And the European Society for PKU and Canadian PKU for their support of this project. We always have to put disclosures. Yes, we patented it so that a company could and would pick it up, which has been successful. Trayer Biotherapeutics has licensed this. That's why they're very interested in making sure we get to clinical trials. And this is about one of the other projects in our lab. So you may find our table over there with all the other clinical studies. I intentionally chose the children's book title. 2 years ago, we requested fecal samples so that we could study the gut microbiome of PKU patients. Right now, we're looking for adults for a number of reasons, so 18 and up. We sent out forms, we sent out sample kits. Anyone want to guess how many samples we got? 1. You can compare nothing to 1. So this time we decided we were going to be smarter, and we sent all the sample kits ahead of us so that they arrived at the hotel before we did. So out there we have the sample collection kits and the forms so that you can bring us your sample before the conference is over. While you're here in those 2 days, you're going to have to go, and I know it, so we've got you cornered. At this time, we're trying to get at least 10 PKU patients and several healthy controls. The first 50 people that bring us a sample back get an Amazon gift card mailed to them, so there is some incentive. Whether you are, for PKU, it doesn't matter if you're off diet, if you are only diet, whether you're on Kuvan, whether you're doing the PEG-PAL, we want to look at all of it. So if you're willing to give us a sample, we're willing to analyze it. And let me tell you, when we get lots of samples in for some things, like when we had the entire lab, about ankle deep in cow poop, it's an interesting day. So